Hello and welcome. I'm Jonathan Hill and I'll be your MC today. Today's webinar will highlight some of the new features of Simcenter and NX11, focusing especially on the CAE features of Simcenter 3D. Our host will be Jonathan Buck, who's a longtime NX and now Simcenter user here at ATA. But before I turn it over to him, I'd like to give you a brief intro into ATA. Most of you know ATA either through our role as a Siemens partner and reseller or through our robust engineering services. We're able to put the value added in value-added reseller because of our experience in providing engineering services across a wide range of industries. We're solving many of the same issues as our software customers, which really allows us to provide exemplary support. On the services side, our focus is on analysis and test-driven design. From ground vibration tests on state-of-the-art aircraft, analysis of the next generation of spacecraft and planetary rovers, and helping to ensure the safety of roller coasters and other amusement park attractions, ATA is here to help our customers meet their toughest engineering challenges. And of course, being experts with Siemens PLM software helps us do precisely that. On the software side, here are the Siemens product lines that we use and can help you out with, whether that's through license sales and technical support, or by training your engineers to use these tools to their fullest capacity. I'd also like to point out that ATA develops the official NX Nastran training materials and is the preferred training provider of NX Nastran North America. We also host a variety of other classes, which range from introductions to CMAP or FEA, to dynamic response, super elements, optimization, and the list just goes on. You can find a full listing of the available classes on our website. Speaking of which, many of you have probably seen the website when you were registering for the event, and this is a place that you can find software product information, links to download free trials, info on our upcoming training classes, and more. For existing users, you'll find a link to our hotline and an ever-expanding array of free resources, such as white papers, training videos, tutorials, and APIs. I'd invite everyone to check out these resources after the webinar, so without further delay, I'd like to turn it over to Jonathan for the main event. So, Jonathan, take it away.
Thank you very much. I am your other Jonathan and the presenter for the latter half of this presentation. And before I begin, or before I dive into the NX CAE material, I'd like to begin by giving everyone on the line a high-level overview of this new branding effort that Siemens is coming out with. I expect that it may be very new to those of you who aren't very dialed into. I'm pausing here briefly. It sounds like there might be some static on the line. I'm wondering if that's just me or if anyone else hears that.
Yeah, we're hearing some kind of echoing or feedback.
Okay. Well, please stop me if it gets too troublesome. Otherwise, I'm going to keep moving forward here, and maybe it's been resolved. So as I was saying, Siemens has been rolling out a bit of a rebranding effort, and unless you're very dialed into the Siemens ecosystem, this may be news to you. And so I want to just give you a feel for the lay of the land as Siemens moves forward. The diagram you see on the left-hand side shows this term called the Simcenter Portfolio, which is this branding effort that Siemens has begun to roll out with the release of NX11. And the reason for doing this is because they're really trying to unify all of their analysis tools for predictive engineering analytics under one umbrella term or one umbrella brand, and that's this idea of the Simcenter Portfolio. And as the graphic suggests, the Simcenter Portfolio is their way of encapsulating all of their 3D and CFD simulation tools. So these are the tools where the geometry is really an integral part of the simulation process. I think that's probably very familiar to many of us on the line. It's also their way of encapsulating their 1D or control simulation tools. And by 1D, what they're really getting at is the idea that the geometry itself is not really crucial to the simulation. So these would be tools that let you simulate control systems and things of that nature. And the final piece of the puzzle that fits under the Simcenter Portfolio is testing and physical simulation. And then around this entire portfolio, these simulation tools are augmented by multi-physics capabilities because Siemens has over the years, acquired a number of different simulation tools that enable a whole range of different coupled multi-physics solutions. And it also allows for an increased degree of design optimization and design exploration, because you can now consider this wide variety of simulation domains simultaneously and leverage a lot of the optimization tools that Siemens has within the context of any of these multi-physics domains. And finally, these solutions are also available integrated inside the Teamcenter environment to enable data and process management and provide complete traceability within the PLM ecosystem. Now, this next slide speaks to the point that I just previously mentioned, that one of the underlying reasons for this rebranding is because over the years, particularly in recent years, Siemens has really made a big push to acquire a number of different analysis tools or simulation software vendors, and it's really trying to bring everything under one umbrella, hence the Simcenter portfolio, and really tightly integrate all of these tools so that everything can be available to you from within a common interface. And this graphic just identifies a couple of the simulation tools that they've acquired in recent years. They acquired a company called LMS a few years back. They had a big tool called Virtual Lab that was in some sense a pre-post processor similar to NX CAE. They also had a simulation tool called Samtech that was a structural analysis tool similar to NX Nastran. In addition to all of that, they've had a number of other new and emerging capabilities. Some of you may know that recently Siemens acquired CD Adapco, which has a CFD solver called Star CCM. And so really the idea behind this Simcenter 3D solution is to bring together all of these 3D analysis tools for structural, thermal, fluids, heat transfer, and just bring it all together under one umbrella. And so if we drill down and look at the 3D aspect of Simcenter, there's a number of different multidisciplinary domains that are now available to you as Siemens customers, including structures, dynamics, durability, composites, thermal, flow, motion, and acoustics. And it's all available within one unified environment. And so even though the name is changing from NX CAE to Simcenter 3D, if you're familiar with NX CAE, then the good news is that the interface is exactly the same. It's just a matter of nomenclature. And so all of these different simulation tools are now being exposed to you through the common interface formerly known as NX CAE. And by virtue of doing that, all of these disciplines can be integrated in a very user-friendly way. And at the same time, because NX is a very open and scalable environment, if you have models that were written in a format appropriate for a different solver, that can be imported into Simcenter 3D. It can be exported from Simcenter 3D, so you can still use it as a pre-post tool, even if you do want to use a different solver to actually do the solving. And that last box on the slide really speaks to the overarching goal of Siemens here, which is to be the worldwide leader in system simulation and bring together all of these different analysis domains and expose it to you with a common interface so you can be as productive as possible. So, having said all that, I'll dive into the next section of the webinar this morning, which really focuses on the enhancements that have been made to the CAE portion of Simcenter 3D. And broadly speaking, these enhancements fall into 4 categories, which you see in bold blue font on this slide. One category is mesh robustness and new techniques. There have been a number of new enhancements related to increased mesh regularity, increased mesh quality. So a couple of the examples you see on those on this list of bullets include structured meshes on trimmed cylinders. Previously, you had to do some tricks where you introduced edges along cylinders to force the mesh to follow the axis of the cylinder. That sort of thing has been dramatically improved. There's additional controls to give you additional tolerance for mid-side node placement, greater control for manual abstraction if the mesh doesn't come out quite the way you want, a number of enhancements to adaptive analysis, as well as a number of meshing tools that are specific to acoustic modeling, if that's something that you're interested in. Another category is expanded solutions. And so this largely has to do with the fact that now the pre-post aspect of Simcenter 3D now has to accommodate all of those multidisciplinary domains that you saw in the previous slide. It's not just the structural analysis domain that many of the NX Mass Train users may be most familiar with. So for instance, this includes boundary element method enhancements to support acoustics and vibroacoustic analysis, enhancements to support Fourier and cyclic symmetry analysis, an additional level of support for multiphysics. There's a couple of new element formulations that are called chalking elements and cohesive elements. Loads can now be prescribed as tensors. Pressures can be prescribed in 4 dimensions. And along with cohesive elements, there's now an additional level of support for progressive ply failure and cohesive damage, which is something that comes into play particularly for laminated composite materials. The third category has to do with post-processing robustness and new techniques for post-processing and interrogating your results. There are a number of result probe extensions, enhancements to allow for post-processing of Fourier modes and cyclic symmetry, enhancements to the report writer, as well as enhancements to the capability that allows you to save and restore multi-view layouts. For acoustic analysis, where you are interested in displaying results in octaves, you can now scale the abscissa of plots using octave bands, and you can also graph paths on surfaces. Now, the fourth and final category is a bit of a catch-all category. It's an assortment of enhancements that don't fall into any of the previous 3 categories. One enhancement that I'm a big fan of personally is this new enhancement to the quick pick feature that allows you to highlight secondary features of parent bodies when you have your mouse in an area that's really cluttered and crowded with bodies and faces and edges and those sorts of things. And previously it's been very difficult to ascertain exactly which face or which edge you're selecting. And you'll see an example of this later on, and I hope you'll see that it can be quite helpful in navigating through those complex displays. There's an assortment of enhancements to support acoustics, multivariate, and cohesive materials. A little enhancement to allow for selecting circle areas. Previously, you've just been restricted to selecting box areas. And a few enhancements to support the visibility of 2D and 3D element normal directions. Now, in the next set of slides, I'll dive through and describe some of these in more detail. And I'll start with the meshing enhancements. In the domain of 2D meshing, there's greater support for establishing your own element quality metrics to really drive mesh quality in the direction that you want. So there's some controls that you'll see on a subsequent slide that lets you prescribe a greater degree of minimum and maximum angle thresholds, for instance. And those of you who are big meshers will know that there's been a feature in the 2D mesher for a couple of releases now called MultiBlock Decomposition, and there's been a significant enhancement in this MultiBlock Decomposition capability that also gives you more structured meshes right out of the box. Now, when it comes to 3D meshing, there is greater support for higher mesh quality on cylinders. I mentioned that before, that previously you had to have seams or edges down the length of the cylinder to really get high quality 3D meshes. Well, that's been significantly enhanced, so you don't have to divert your meshing workflow to create geometry artifacts just for the sake of getting higher quality meshes. In terms of polygon geometry operations, there's a number of enhancements to enable merge face preview and smart selection, as well as additional ways to abstract geometry so that you can capture more fine-grained features in your meshes that may have previously been abstracted away and going from the underlying part geometry to the idealized part to the CAE bodies. And another big area of enhancement is this bullet that you see on the right-hand side, adaptive meshing. This is a way of having the software iteratively refine the mesh for you in cases where you're not entirely sure what the appropriate mesh density is, or you have certain stress concentrations that you don't want to unduly bias your results. And so there's a number of controls that let you specify keep-in zones and keep-out zones for the mesh refinement, identify zones where you expect singularities to occur, although having said that, there is also support for automatic identification of singularities. And as part of this process, you can have NX store intermediate results and models so you can visually inspect how the mesh is refined throughout the adaptive process. There's a number of other meshing enhancements. This first one I quite like. It is a quick and easy way to create lump masses at the CGs of polygon bodies or even a number of bodies and sort of group a number of bodies and have the software treat that as effectively one body and create just one lumped mass for a number of solid bodies. So previously, you might have had to do a bit of manual work to identify dimensions of solid bodies and identify the center point and or potentially do some math on your own if it was a non-uniform body or a non-uniform material. There's a new enhancement to create multiple projected mesh points in a single step. I also like that one because that used to be a fairly tedious manual operation if you had a number of target points or geometric points that you wanted to project onto a surface to create mesh points to drive or force the creation of nodes during the meshing process. That's now much more straightforward. There's another great enhancement to detach and unzip elements from surrounding elements, and I'll show you an example of that in a subsequent slide. Along with detaching or unzipping elements, the counterpart to that is attaching elements through a local remeshing process. You can fill holes in a mesh without having geometry explicitly to explicitly define the hole. There's a number of enhancements that are really related to acoustic analysis workflows, but they might be relevant to you even for more general meshing operations. There's a very handy way to create convex meshes. So if you have a body that you want to enclose with a convex surface, that's now a very easy operation. And if you are interested in acoustic meshing in particular, you can specify the element size using the frequency as an input. And the reason for that, for those of you who aren't intimately familiar with acoustic analysis, if you want to have high fidelity results, it's important to make sure that your element size is such that you can capture the resolution of the frequencies that you're interested in. There's a mesh wrap for acoustics, which is similar to this idea of creating a convex mesh around a body. There's an enhancement to the surface coding algorithm to automatically detect and filter out solid element free faces at locations where you might have hexahedral to tetrahedral element interfaces. And lastly, there has been an enhancement to the 0D meshing command that now lets you use a geometry-weighted distribution of mass. Okay, in the next set of slides, I will show you a few examples of that previous bulleted list, just so you can get a visual feel for what these commands look like, what kind of use cases might be appropriate for them, and what kind of results you can expect. So this first slide shows an example of the Detach Elements command. So in this example that you see in the image on the bottom left of the slide, you see a tapered cylinder with two ribs sticking off the end of it. And in this use case, what you might want to do is you might want to break off those ribs from the cylinder and maybe have a different means of connection. And so what this does is creates coincident nodes at the detachment location. So in this case, that would be the edge along the interface between the rib and the cylinder. And then after the coincident nodes are created, the element connectivity is redefined so that the elements are no longer attached. And this example shows a 2D use case, but it's also applicable to 3D elements as well. The counterpart to detach is to reattach elements. So in this case, what you see on the bottom left is the exact same geometry as we saw on the previous slide, but now as you can see, the elements are no longer connected. The elements do not have nodes in the same locations. And so the way this mesh was created was the bodies were separate and meshed individually. And in this use case, what we might want to do is reattach these ribs to the underlying cylinder And so the edge, the location of interest is shown where you see this edge highlighted in orange. And so what this command does is actually, it does a local remeshing operation, and you can see the result of that in the image on the right-hand side. And you can see on the cylinder where we previously had nice regular quadrilateral elements, we've now introduced a number of triangle elements for the sake of getting nodes to fall in the right location so that the cylinder can be reattached to the rib. Now, unlike the previous command that worked with 2D and 3D elements, this only works with 2D elements. The next command I'll show you is creating a convex mesh for acoustic analysis. So this mesh you see on the bottom left might look very similar to the geometry you saw in the previous slide. It's a tapered cylinder with ribs coming off it, but now the difference is we have thickened those shells into solid elements. And the use case here is we want to create a mesh that surrounds this body, and because it's a cylindrical volume, we want elements to pass through the center of the cylinder as well. And so previously this may have been a very tedious manual set of operations, and now it's all encapsulated in this convex mesh command. And so what you see in the image on the bottom left is you see the cylinder and rib body shown in green, and then surrounding that, you see this convex mesh and the translucent gray elements. And then on the right-hand side of the slide, the image you see is a cutaway view of the convex mesh with the cylinder removed. And so you can see the cavity that's left in the convex mesh after removing the cylinder with its ribs. The next command I'll show you is the command to fill holes in a mesh. Now this command is actually called mesh from boundary, and the use case here may be that you have existing mesh but no underlying geometry, or maybe you do have the geometry but all you want to do is fill a hole in the mesh. Maybe there's a hole or a cutout or a slot or a notch or something along those lines, and you're really just interested in filling that hole with elements without going all the way back to the geometry and doing a substantial remeshing effort. And this command is very straightforward. All you do is you select the boundary or the closed loop defined by a certain number of element edges, and that's what you see highlighted in orange in the uppermost picture. And then in the bottom, you see these light blue elements that represent the elements that were created to fill the hole that we defined in the previous step. The next command I'll show you is a command to remove ribs from a finite element model. Now this is an interesting command because it actually operates on the finite element model itself and not the underlying geometry. Now this can be a manual operation. You can select elements individually and have them removed from the mesh such that the element connectivity of the remaining elements is still in place, or you can take advantage of some automated smart selector capabilities to automatically infer what the rib should be. And so the image you see on the left-hand side of the screen shows an example of the dialog box. The command is called remove ribs, and there's some checkboxes and tolerances you can specify to help the software identify what should and should not be considered a rib. So in the image that you see on the right-hand slide, the elements that are highlighted in red have been identified correctly as a rib. This is somewhat of a minor feature in the context of this structure, but you see this other plate that's parallel to the red elements has not been identified as a rib. And I think in this use case that is the desirable outcome because this is a more major feature. The next command I'll show you is really not a command so much as an enhancement to the 2D meshing command that I'm sure many of you are familiar with. What you see on the left-hand side of the screen is a picture of that 2D meshing dialog box, and those of you who are very familiar with 2D meshing in NX will know that for a couple of releases now there has been this checkbox that's labeled Attempt MultiBlock Decomposition. Now this MultiBlock Decomposition algorithm has been enhanced in version 11 of the software, and if you look at the meshes that you see on the bottom right side of the screen, you'll see the results of this enhancement. So the first mesh that you see with light green elements has a number of triangular elements highlighted in orange. This represents the outcome of the meshing operation without multi-block decomposition. And on the right-hand side, you see the outcome of the mesh with multi-block decomposition enabled. And you can see we significantly reduced the number of triangular elements we have in the mesh. The next command I'll show you is, again, not so much a new command as a new enhancement to an existing command. Again, this is the 2D meshing command. What NX has now introduced are a number of new mesh control quality objectives. And these are shown in the box region in red in the picture of the dialog box that you see on the left-hand side of the screen. And these were commands that were not previously available to you as a mesher or an analyst. So now you can specify the maximum and minimum included angles for quadrilateral and triangular elements. Now, one of the other new capabilities that have been introduced to Simcenter 11 is significant support for analysis of composites, and particularly for analyzing the failure of composites. Those of you who have some experience with composites will know that they are quite a bit different than traditional metallic structures in that they don't exhibit a very large degree of ductility. Their failures are often brittle, they're often sudden, and they're often characterized by multiple failure modes. You might have in-plane failure modes where the fibers of the matrix split. You might also have inter-ply failure modes or delamination where the plies separate from one another. And so there's now a wide variety of pre- and post-processing tools in Simcenter to allow you to model these materials and capture their failure properties. And so just to identify a few of those new features, you can now capture delamination damage with cohesive element material models. You can model the plies using orthotropic damage material models. The solver now is actually capable of not only simulating what we call first ply failure, but also progressive ply failure. And that's key for composites because oftentimes when you're simulating composites, if you stop the simulation as soon as damage occurs anywhere, that can often be somewhat of an over-conservative analysis approach because the load has ways of redistributing as damage progresses throughout the structure. And so that kind of progressive damage can now be simulated using the solvers built into Simcenter. One of the other new capabilities within the domain of NX multiphysics is support for user-defined materials. And so what this allows you to do is really take complete control over material definition. So if for whatever reason you find yourself needing something above and beyond an isotropic, orthotropic, or even fully anisotropic material model that's already built into Simcenter, now you have the ability to really define the material in any way, shape, or form that you see fit. Now, as you might expect, there are some setup steps you have to go through to enable this. In particular, you have to compile libraries if you're on Windows or shared objects, or if you're in a Linux environment, to represent the material model in such a way that it can be accessed by NX Nastran during the solution. There have been enhancements to the application of bolt preloads. Previously, bolt preloads were either enabled or disabled, and you either got all of the bolts in the model or none of them. Well, now there's a capability that allows you to progressively apply preloads to bolts individually, one at a time, or sequentially. There's a number of selection and graphics enhancements. Some of these are small, so there's a few different enhancements laid out on this slide. The first bullet point shows you that you now have the capability to use a lasso select or a circle select. I think that's something that many people have been asking for quite some time. The second bullet shows you something that I find tremendously useful. It's an enhancement to the quick pick mechanism that highlights secondary features in cases where the selection is ambiguous. And that's what the image on the left-hand side of the screen shows. So suppose you're in a case where you want to select the interior face of this green block. Now the problem you'd run into, and the confusion you'd run into in previous versions of the software, is if you were to hold your mouse over the middle of this body and wait for the quick pick dialog box to pop up, it would tell you that there were two faces there. One face belongs to the green body and one face belongs to the gray body. But identifying exactly which face you were selecting was somewhat ambiguous. But now the software clearly guides you into identifying which body is related to a face or an edge or a point that you're selecting. So in this case, what you see is that the green body is highlighted in this blue outline. And so that indicates that the face that I've selected, which is highlighted in red, belongs to the green block. And again, that's available not only for selecting faces, but also edges, points, and even nodes and elements if you're working with a finite element model. And lastly, there have been 3 new formats added to the view layout. And that's shown graphically with the images you see on the bottom of the slide. On the right, you see the layouts that were available in NX10, and on the left, you see the layouts that are available in NX11. Another enhancement has been to the way that element normal directions are visualized for 2D and 3D elements. Previously, you were limited to displaying vectors that corresponded to the element normal directions. And once you got to a model that was any decent size, that could become quite cluttered because then the arrows would overlap. It's difficult to see exactly which direction they're pointing. And the difficulty was you could zoom in, and once you got zoomed in enough on a local level, you could identify the arrows. But at that point, your view was so zoomed in that you could only look at a handful of elements at a time, and it was really difficult to visually scan the entire structure or the entire model and look for spurious element normal directions. And so the big enhancement here is a way of visualizing those normal directions that corresponds to a color scheme. In this case, the colors red and green are used. And you have the flexibility to change those colors to any color you want. But the bottom line is this provides a quick and easy graphical way of inspecting whether or not all of your element normals have consistent directions. And so what you're seeing in this image is that there's one element on the top of the hub and one element on the side of this cylindrical face of the hub that have element normal directions that are inconsistent with the rest of the model. Now that covers a wide variety of pre-processing enhancements. There have also been a number of post-processing enhancements as well. In particular, related to the results probe, there have been a number of enhancements. In particular, you can simultaneously graph multiple probes in a single grid or a stacked format. You can restrict the display to just a portion of the model. You can export result probes to a universal file. One new feature that I find quite helpful is the ability to copy within a sim or across different sim files. There's also enhanced support for plotting result probes along a user-defined path, as opposed to forcing your result probe to follow a geometry edge or element edges. You can now define your own path. And result probes are now also subject to, are available to math operations, so you can do various linear combinations or interpolate in time and space using result probe results. There has been an enhancement to the banded display, and so now there's increased visibility between the color bands, and I'll show you a really good image that shows you sort of a before and after look at that enhancement. You can save and restore multi-view layouts and view contents. Previously, your views were restricted to just a single view pane, and so if you were ever post-processing or visualizing multiple models or multiple results using multiple panes, it was difficult to really save the entirety of that graphical display. But now you have that capability. Another enhancement that's quite handy is the ability to define a reference node for displaying contour results. Or to put that in other words, what that means is you can display contour results relative to a particular node, and it doesn't always have to be relative to your absolute global coordinate system. Now lastly, there's also been a significant overhaul of the report writer system. Reports are now saved in Microsoft Word documents, for instance, and there's significant flexibility for taking some example templates that have been provided and customizing them or creating your own templates to really streamline the process of creating documentation that's really tailored to the way your organization creates documentation. There's also some example report components that are provided using NX Open Code, and you can create reports automatically or interactively depending on the skill level of the user. So let me tell you about a couple of the result probe enhancements in detail. One feature is you can contour plot a subset of the entire model. So when you are using the result probe, you can show contours on just a single portion of the model, or and you can use that feature using groups or geometry definitions. And so that's a handy way of showing contour results and geometry at the same time in the same view, for instance. You can create result probe output immediately, and what that means is previously what you've had to do is display a contour result and then click through a few dialog boxes to turn on or enable the result probes. But what you'll see on the bottom right-hand side of the screen now is there's a checkbox to automatically create output for you right when you get to the post-processing window. You can create XY graphs using multiple result probes at once, and you can stack those graphs if that is a sensible way of post-processing your results. The other thing that's handy is you can copy result probes to other solutions within a single SIM file or even across SIM files, and that's also handy when you're cloning solutions, for instance. So if you have any custom result probes that are defined and useful for your particular post-processing scenario, you can really leverage those result probes in different simulation files. And then one final thing you can do is you can query results along a path by creating your own user-defined curve along mesh points or nodes or polygon edges rather than being restricted to the somewhat more limited way of creating result probes. This slide speaks to the enhancement to the banded display, and I think the picture really says 1,000 words here. The picture you see on the left side shows the default banded contour plot, and this was the only type of banded contour plot that you could get in all previous versions of the software. And on the right-hand side, you see the banded contour plot with ISO lines that divide the different color bands. And this is really just a qualitative visual way of making it immediately clear where the divisions are from one contour band to the next. This is a slide that speaks to the new feature that allows you to display contour results relative to a particular node. And so this example model you see on the left-hand side of the screen is a cantilever plate. It's fixed on the back left end where you see the coordinate system, and there's a cantilever load applied to the right-hand side. And if this image looks a little bit funny to you, that's probably because every time you see this type of cantilever structure, you're used to seeing blue colors over near the fixed end and red colors over near the end to which the load is applied. But what this image illustrates is that you can use this new feature to display results relative to a given node. And so what I've done in this example model is display results relative to a node at the very right end of the plate in the center. And so even though the right end of the plate experiences the most deformation, it's actually been scaled in such a way that the fixed end shows up red. Now, when it comes to NX multiphysics, there's been a number of enhancements to support post-processing of cyclic and Fourier normal modes. So for those of you who may not be familiar with these types of analysis, if you look on the left-hand side of the screen, you'll see an example of this new support for cyclic normal mode. So what we've done here is we've taken just a small sliver of this engine manifold. It's still a 3D solid body, but rather than mesh and analyze the entire engine, we just want to work with this one sector for the sake of computational efficiency. And what the model does is adequately extrapolate the results all the way around 360 degrees of the engine manifold. And so you can model and analyze just this individual sector and yet still get results and display them in a way that's perhaps more meaningful, because when you see results displayed on the entire engine, I think that's just easier for everyone to wrap their heads around and understand the results rather than looking at the results on just this one individual sector. Now, the images you see on the bottom portion of the screen show results that you can get from Fourier normal modes. And in this case, we're working with just a small sliver of this structure, but in this case, it's actually a 2D model and not this 3D model that we had in the previous example. And so what you can do here is solve for the modes of this 2D sliver and then extrapolate the results 360 degrees around the structure, and you'll see that what the result you get is a result that actually accounts for some non-symmetric modes of the structure, or a mode that you would not necessarily be able to get if all you had analyzed was just this 2D sliver in isolation. And so what the software is able to do is look at this 2D sliver and actually understand how the mode shape should evolve or progress when you look 360 degrees around a circular structure. Now, that addresses a number of enhancements to the CAE portion of Simcenter, but I also want to take just a minute to talk about a couple of enhancements to the CAD side of Simcenter. In particular, there have been a number of enhancements to the surface modeling capabilities. And really what this is all about is creating some new tools to help the user create complex shapes in fewer steps with better accuracy. And so, for instance, what you can do is create scaled copies of existing geometry using a new scale curve command. One thing that I think is going to be tremendously useful to the users out there is the ability to flatten, modify, and reform curved surfaces. And I know as a CAD user myself that working with curved surfaces can be tremendously difficult, because oftentimes what it involves is creating tangent planes and then understanding how a sketch on a flat plane projects to a curved surface, and then trying to figure out whether or not that really captures the design intent. And oftentimes that's sort of at odds with the manufacturing process anyway, because rarely are manufacturing operations performed on curved surfaces. They're formed on blanks or flat parts that are only then curved and bent and shaped in the final part of the operation. And so this ability to flatten, operate on, and reform curved surfaces, I think, really goes a long way towards addressing some of those difficulties. There's also additional support for enhanced trimming of sheet bodies, as well as new capabilities that allow you to create a body with variable thickness. In the domain of sketching, there are a number of easier controls and better access to information that allow you to get the right sketch that you want the first time. So for instance, one of the new features is just a little tooltip that shows you automatic dimension display as you're sketching in real time. You can scale a sketch around a sketch origin or even around a particular driving dimension. There are more options for constraining to vertices. There's a really handy dialog box now called the Sketch Relations Browser that makes it very easy to see the relationships among various objects in your sketches. And I think if any of you are like me, you've certainly sketched yourself into a corner where you have a sketch that's over-constrained, and then you're never quite sure what sketch objects are related to what sketch objects. and what the fastest way is to delete some constraints to get yourself out of that over-constrained situation. And that's what the Sketch Relations Browser is really designed to address. So you can very easily and clearly see those relationships and make the right decisions as to which sketch objects need to be unconstrained so that your sketch isn't over-constrained. There are also new capabilities, a new way to create splines. There's a simplified sketch creation dialog box just so that it's a little bit more intuitive, particularly for new users when you're looking at the dialog box and you're not overwhelmed with the plethora of sketching options that are available to you. And last but not least, there's greater user control over display options just to get better performance. Sometimes sketches can be pretty big and cumbersome, and there's a lot of information that isn't always immediately relevant or doesn't always need to be shown, and you now have the ability to show and hide some of those sketch objects or parameters just to get better graphical performance. Now I'll show you a couple examples of these things, starting with the sketching enhancements. The dialog box you see on the top right-hand side of the screen shows this new Sketch Relations Browser that I talked about on the previous slide. And so you can see it's a really user-friendly way to kind of navigate through this tree-like structure that breaks down all of your sketch curves and shows curves that are derived from them or dimensions that pertain to those curves. The other thing you'll see in this image on the bottom right is the ability to display dimensions automatically and scale dimension or scale sketches around the sketch origin or even around particular driving dimensions. And as I said on the previous slide, there are a number of new enhancements to simplify spline creation. The sketch dialog box looks somewhat more simplified, and there are controls to choose exactly what you do and do not want to have displayed just for the sake of greater graphical performance. Now when it comes to surfacing, the image at the top right illustrates this new feature that allows you to flatten a surface and then reshape the surface to its original curve. What you don't see in this image is perhaps the original incarnation of the surface before it's flattened. But now you can take surfaces, flatten them as you see in this gray sheet body, then you can do all your sketching. You don't have to worry about tangent planes. You don't have to worry about how these objects may be projected from the tangent plane to the ultimate curved surface. And because you're now working on just a single plane, you can do all your sketching in one go. And then using the original parameters of the originally curved surface, you can take this flat sheet body and reshape it to match the original curvature of the original sheet. And now the image you see on the bottom right shows some of the additional capabilities for trimming sheets. There's some new enhancements to make it easier to trim sheets at divisions or places where you have step changes or changes in directions and the sheet goes from one plane to another plane. Well, that concludes our webinar this morning. I want to thank all of you for attending, and I hope you've been taking notes out there because there really are a very large number of new features in Simcenter 11. I think moving forward, you'll hear more and more people from within Siemens, and certainly here at ATA, referring to NX as Simcenter because we're really excited about all of the new features that are being added to Simcenter to really enable all of these new multidisciplinary capabilities. If you have any questions, we'd be happy to take them on the line, or you can reach out to us using the contact number you see on the slide or the email address. Jonathan, Dan, any concluding remarks?
I think unless there are other questions, which it doesn't sound like there are, I'd just like to invite everyone to keep a lookout for a survey you should be receiving soon. It's super quick, and it helps us out a lot just in terms of making sure that we're providing webinars that meet topics that you're interested in and just really helping us provide better resources for you. So I invite you to keep a lookout for that, and we would love to hear your feedback. Other than that, thank you so much, Jonathan. Great job.